So, hello. Today we're going to have an overview of Goa. I am Alexander. I work at Intel Security, and I love Go, and we love Go over there. And we use Go for half a dozen of our services. And so we contributed as a group to the security layer of Goa. So we're second contributor, I think, to Goa today. We're proud to offer also all of our teams a great and solid Swagger documentation, open API, to interface with our machinery. So raise your hand if you know about Swagger. Right, so for those who don't know, Swagger is the specification thing. Swagger has been renamed to Open API, and it has great tooling for a whole bunch of, this is stuck thing. Okay, there's a whole bunch of tools around Swagger. So when you define with Swagger, then people can generate all sorts of things around. Goa is a small framework for building microservices in Go. Okay, it has a sort of DSL, a way to define your API using code. It's actually just Go, so it's the DSL, but at the same time it's just Go. We're going to go through that today. It's inspired by Gomega and Jinko, if you know those testing tools. And the idea behind Go is that you want to handle all the API lifecycle. And the API lifecycle is from thinking to the design, implementing the design, rolling it out, and then iterating on your API. And as you know, maybe you've tried that. You built an API. Raise your hand if you built APIs earlier on. Right, exactly. So just so you know, you need to ask questions during the talk and raise your hand, and then I send you chocolate. Okay? So you can interrupt me. So like you've started writing an API, and then the consumer of the API comes and looks at your thing and says, like, I want users with their roles. What the hell is that /pumpkin thing, right? I want users from your API. And didn't know that before, because the other guy didn't see the real concrete meat of your API until you showed him a documentation or something, right, concrete. And so you'll change your API and such. So that's an iterative process, right? And also the documentation. In a microservices world, well, the documentation or the API is your communication with the other teams, right? You're going to give them that, they're going to consume it, and if they cannot talk to you and just read the thing, that'll be great. Another thing is, like, how many times, I don't know you, but how many times did I look at documentations that was outdated? Did that occur to you? Like, you receive a docx on a Friday evening, and it's not up to date with the implementation, HP3 or something. So that happens all the time. And it's very difficult if you go the other way around, build your implementation and then try to craft the docs. Whereas if you start with a design that can generate your documentation here in Swagger file, and also help you out with all sorts of boilerplate stuff in your implementation, then it's a big win. And it also makes the design a single source of truth. You want to look at that, you want to modify that, everything scaffolds from now. And the interesting thing is that it's pretty generic, right? You define the design, and then Goa has pre-loaded with generators for documentation, Swagger, for clients. So if you want to consume your API with another Go program, the client is already there, like new client and such. A command line tool, and then the JS library too. So you can consume it through the web. And also the server stub implementation and JSON schema nut. And you can generate your own, because it has a nice, beautiful, abstract structure that you can then loop around and generate your things. So when you think of building an API, right, you start with thinking of the API. So that's the design phase, right? Design first. And then you revise it with your team, so you iterate, and then you implement the thing, right, after learning that you don't need to implement half of it. Hopefully you learn that before implementing it. Then you test it just a tad, and then you ship it to prod, and then you tweak it, and then you ship it to prod again, right? So we'll see what we can do in these things today. I have a simple idea. It's not a good idea, but you know, I love puddings, and we want to build a classifier thing for puddings, and maybe functionalities to blend puddings together, to make them taste better or something. So let's say a pudding has a name, and it could be tasty or not. And there's ways to make it better, right? Is it hot or cold? Does that make sense? And this is the API we're going to build. So what if we wanted to list all the puddings, pretty standard REST here, right? To create a new pudding, get the pudding for a single thing with an ID, and delete the pudding, and maybe have some blending function. We'll see if we want to do that. So that maps to this here in Go, right? But we're going to build that with Goa from scratch right now. So we're going to create the pudding directory. I need my sheet, my paper. I'm nothing without the paper. You had a question? Oh, no, that's fine. Well, it's chocolate for you. If you had a question, you had no question. So we're going to start here. I brought that up. We're going to start here with a design. Oops. So in pudding, we're going to create the subdirectory design. I'm going to put an API in here. I'm going to create the directory. And this package is going to be the design package. And I'm going to .import github.com Goa design. That's the name of the repository. And we're going to use that one here and API DSL. .imports. You didn't want a dark chocolate? So the .imports, for those who don't know, brings up all the symbols that are exported in the design here, for example, okay? Let's say all these things in, so this one lives in Goa design, Goa/design, that's the remote product. Everything that is exported in there will come as first class element here. That's how we'll be able to use API pudding. Right? So API comes from API DSL. It's .imported, so we don't need to prefix it. Everything is blended together here. That's the .import. It's discouraged, but here when you write a program, it's discouraged to do that because this makes things hard to know where it comes from. But in here, we're using a simple DSL. We shouldn't be importing other packages to do other things, like it's just a DSL. So that's okay. And in there, so we can define a few things like pudding master. And the description here, we could add a version. And let's say we could add a host definition. Because when you send that to your colleagues, well, you can also tell them where to reach it. You'll have directly in the documentation, let's say the real host name. So you send them the Swagger file, and they can try it right away with a UI that will try it. We'll see that. And all of our API here is going to be stacked on /v1. Because maybe later on we want to do v2. Good practice to version your things, okay? And this builds an API, Swagger file, and we'll start with the server. Let me add just a little bit, and we'll generate and see the things that are generated here. So the other thing I want to build is the pudding object, the model. Here we're going to define it with the DSL. We're going to call it a media type, okay? And media types, so again, deep pudding JSON, you've seen that sometimes. Media types are things that are returned from an API. It determines the type, content type tag, and a header in an HTTP response. And so consuming application can distinguish the thing that's coming through. Okay? And that also will use that. That'll build our Go struct. But we're going to define it this way. When defined this way, we can generate all sorts of things. It's more flexible than just a Go struct. Okay? So putting a recipe, and then we'll have attributes here. All right? And the first one is going to be a string. And we could add a description. So that will be like the recipe name. Right? And we had in our model, whether it's just tasty, and all these Boolean things, like tasty or not. All these are types that are defined in the API DSL. Do you have any questions? Following up? And then would be better, that'll be a string, but so here we're using Veridic, and we can add other things like hot or cold, right? These are things we can't easily define on Go structs, but here we have a lot of flexibility. And if we do that, Go is going to help us a lot because it's going to scaffold all the code to validate that any incoming request matches that. It's going to hard code, like a check, if the value is hot or is not hot or not cold, then we'll send an error back to the user. It's very solid. It makes a very solid API. Yes? Ingredients? Yes. An attribute could have, like, let's say you define ingredients here with the media type separate, or a user type. There's a distinction. User types are just standard types. Then you could have an attribute that is a whatever other thing. It would be nested. Oh, you have a lot of flexibility in that. Yeah, string just makes it a string. These are sort of validators, right? The enum will also be generated in the Swagger file. Swagger file supports that. So it'll give you a nice drop-down list when you have tooling around, right? Because Swagger file knows about that. Okay, there you go. Yeah. So maybe you've tried sometimes in your life, or no, wait a second, we're missing one piece. We also want to have here what is required, right? So that'll mean a name is going to be required. Those are optional. You get errors if you don't specify them. It will make also pointers to string or just a bare bones string when it's required. We'll see the generated difference here. Now, yes, go ahead. So if you have a required field, no, it distinguished. So maybe some of you guys have used the AWS library, right? They chose in their API or GitHub, the GitHub thing by Google. So they decided that their fields would be a pointer to most of the things, a pointer to a string. So it can distinguish the 0 value from a non-existing value, right? If it was present in the request or not at all, it was an empty string. Otherwise, you lose the empty string, right? So Goa will scaffold the same way to have that distinction, if it was present or not. Great question. So now, sometimes like you want to have different views of your data, right? Let's say you're viewing that endpoint, but you're logged in as admin. So we could define views like that, and we need a default view. Whoa. Default here, and then we'll list here the attributes that are part of the default. Let's add another one in properties here. That will be a hash of string to any, like properties. Just to add a little bit more fun. So a hash of, you can imagine, will map to, in Go, a map of string to interface, empty interface, right? And it will scaffold to as an object and whatnot in the other generators. So let's start with that. We're going to generate using the yet uninstalled Goa thing. Actually, you see it's installed, but so we go here and we go get-v, github.com, and we're going to go guide design. Go, and there's the Goa-gen tool here. So go get will grab the repo here and install Goa-gen for you. If you do that, now you have a Goa-gen binary, right? The Goa-gen binary here is called, and you have a series of things you can create. What I'm going to run Bootstrap, Goa-gen Bootstrap, and I'm going to give the my path here is GitHub Bourget/pudding, and the design lives in oops. You see that? Everyone sees that? Lives in the /design folder. If I do that, it's going to compile my design. Hopefully there's no errors. Maybe there's some. Otherwise, if we had errors, we'd be very precise, like inside that API definition, the description is not allowed or something, right? It's pretty rigorous. And then it scaffolds the app, and then also the main, and a tool, command line tool, and the client, and the Swagger definition, right? That's what Bootstrap does. It's a shortcut for app main client Swagger thing. So let's look at what was generated at first in the app folder. No, in main here. Let's see. So this here is the full file, 24 lines. This is our server. It adds a few middleware things. That's a very thin layer around http.listen and serve. It builds the serve mux here behind, and then listens on that. Right now it does nothing, but it did generate an app, the media types, in which we have, see this one, the type pudding, which has better. It's ready to be serialized as JSON in a form XML. Supports GOB. Also, there's like already ready to receive XML requests, GOB requests, JSON. You can take them out or whatnot. And you have the properties map, string to interface, whatnot. Right? So that's all a valid. And look at the validation here. you can validate that an incoming thing will have, if it's not a nil, will have the right values, and the errors that's going to be returned will be properly marshaled as a nice struct for the callers, right? Looks at the values and such. It's all generated. You need to code that, right? I don't want to code that. You want to code that? No, no.
So the intention is once you generated this, you're not supposed to manually.
Folder is never modified, always fully generated. Each time you run the app generation, it deletes the folder, rerun it. You don't put code in. There's a distinction, it's very important. But the main file I've shown you is the first scaffolding. If main exists, it's not going to overwrite it. You can rename it and then scaffold it again. But you know, if you want to pick up changes, but normally would not pick it up, would not overwrite it. Okay, file exists just for the main. All the other ones, you regenerate everything. So that was a good question. Yes, go ahead. I'm getting to that. Like we had no controllers right now, but let's add a resource. Okay, so we're going to back to the API here. Now we have no resource. Let's write a resource for pudding, right? And in there, we'll have a, I want to put all of that under puddings. So the base path is going to be stacked on top of the API base path. Base path for the API, everything is on top of that. So you have a first class resource. Everything, we're going to specify all the actions here, right? We're going to specify an action with a, let's say if I want to get that, then I'm going to say response OK with a collection of pudding, right? So that get is going to be stacked on top of the base path for the resource it's in, stacked on top of the up there, right? v1 / pudding / slash in that case. And so we can add also a show here. Show will use an ID and will return only a pudding, wouldn't it? But at the same time, we'll want to add params because the ID there, we want to validate that. And in Go, we have static typing. We don't want to receive just a blob of bytes. We want it to be analyzed and converted to an int if it's an int, right? And validate that for the caller. So we're going to make that one here an integer, so pudding index or something. Nope. Makes sense? So that param will map to that one. It's going to analyze, and we'll have it in our context for consumption. Does that make sense? So we're also going to list all the responses here. Like, that could not exist. So we'll document that. It's possible that this thing returns a not found. And adding that will help us because it's going to scaffold helpers for us. And so we'll also want, let me copy that here. We'll want, let's say, a create. That'll give me a post on slash. And so there's no ID. But the payload we'll expect will be a pudding, right, with the name and properties and such. That's what we'll expect as an input. And what we'll send is created. That's what we can send. Obviously, any API can return a 500 error. We don't put it explicitly here, but you could have an error for any other reasons. That's not documented in Swagger files normally. And you have descriptions and then action. Yes. Okay, that's a great question, and you should have another chocolate for that. The blanco or the cacao? Cacao. So all of these functions here, all of these things created and OK and not found are part of Goa, right? They're in Goa design/design, and Goa will automatically, for those things that are built in, map them to their proper error code, which is also listed in the HTTP net, the net HTTP library. Right? They're already mapped. So you will have the right error message. But we're look.
More about the added validation of the source and its create endpoint for taking as a payload as the source, but it might have the validation.
But then it'll tell the user.
Yeah. So those are added in front.
Yeah. So I don't understand the question then. So you say added in the.
No, it's like we add response types, right? Say the response will be okay or the response will be created
yes.
or not found. Then do we need to add the response?
For the errors, no. So a bad error, a bad response, bad request. for a whatever thing. That one will be also generated, and it can occur without you specifying that. Yeah, yeah, it'll be in, true. It's a good point. Oh gosh, you're good, because we implemented security, right? So we can have that. I'm not sure we're gonna have time to look into that, but if you invite me to the caviar dinner or something, I could, no. We'll see, maybe I have a moment for that after, okay? It's not part of the original design of the talk. But there's an article for that. So over here, so you don't get any, yeah, okay, you can have it. So over here, we're gonna add, so the delete endpoint, let's say we want to have this one, and let's add a, I don't know, a delete comment string, right? So a deletion comment. So, and this one can respond, okay, and it could respond not found, right? But for the sake of the example, let's take out that one. Like, we didn't realize that delete needed a not found. So let's take it out, and we'll see. What? I don't understand. This one here? Okay, good point, good point. The ID will map anything that's in there. Otherwise, those are going to be query parameters. If you have a payload, payload is going to be in the body, and other parameters are going to be interpreted from the query string. Make sense? Yes. So Blanco or Cacao? Alas, Blanco, you're good. Okay, and then, so let's see what that gives, right? Let's generate now with this. So I'm going to rebuild just the app and the Swagger file. It all works, man. I don't know, probably someone rehearsed. So let's try the, let's look at the, I want to see what it looks like when using proper tooling. Let's look at the Swagger YAML file. Huh? I'm going to put that in here. That's the generated Swagger file. So let's boot it up. So it created here all the documentation for your thing with the pudding, with the summary. That's the action name plus the resource name. And in here you have, you know, a collection of the media type vendor. You have all the definitions. See, that one is required here. And then you could try this operation. We'll have a cross-origin thing issue, so I'm not going to try it right away. But you know, you could, if you have that on prod, you'd send the request. You'd have in there, let's say the post. See, the body here would be that, and trying it would offer you the parameters for better and such, right? That's pretty great. Object properties and da-da-da. And if it's tasty or not tasty, for example. Isn't that cool? Pretty slick. Now let's look at the generated app. Whoa, let's go back. Oh, wait a second. I'm going to remove the main here, and I'm going to scaffold another time the main. So I'll see. Now it creates the main and puddings. Puddings is the resource puddings, all the endpoints. Now someone was getting there. So that's the main. Now what was changed is that we now mount the puddings controller. And look at that here. It uses app, and app is a reference to the generated app. We're referencing here generated code, which is pretty awesome. Let's look at that a little bit. That's inside generated code, okay? It will expect a controller that implements an interface with those methods. So the moment in my own code, so this here is my own code. That's a helper. It creates a pudding controller, and then it has a create, a stub for create, a stub for delete, and list and whatnot. If I forget one of these, the program will not compile anymore because the interface will not be matched. And Goa's, a big part of Goa's design is to make sure all these things are very tightly interlocked. So when you scaffold a new design, if it breaks your implementation, you'll know at compile time, which is really cool, right? It would be difficult to do that like in PHP 1.5 because you had nothing in PHP 1. But anyway, no, but because if you have a dynamic language, like you don't have that interlock to verify this statically that your code is going to run well after. You need to run through tests and such. So that will be quite a hassle. So, you know, kudos to Go. And let's look at, for example, that create statement. You notice create from pudding's controller. This one is one we control, right? We decide what's in there. We could add a DB reference, whatnot in there. Like it's our controller. It just happens to have a few methods that are negotiated with the generated app. And then we have a series of contexts. See that context here? That one is specific to that action on that resource. Each generated for you. And they happen to match like that with your design. So that create puddings will have, that's inside generated code, will have the payload. And the payload will point to the create puddings payload, which happens to be the exact same thing as the pudding, right? And, okay. Do you think we can implement that? How long do you think it'll take? 45 seconds? An hour? No, we want to ship to prod, right? So, let's implement that. We want to have a store, which is going to be a list of pudding. That's an internal memory store, okay? You would probably switch to FoxPro or some like Borland database that you have on your shelves at home. But right now, we're going to use an in-memory store, okay? And we're going to make that totally not concurrent. So if we create something, we'll want to append in our store a new pudding. And here, we want to create a new pudding, but we'll have in our context, so the name, the payload, right? Because it's not exactly the same object, because you could potentially receive like an object that would not include an ID. Yet a pudding would have an ID. So you distinguish those things and perhaps have an internal representation for an object. And generated code would be from the exterior, right? Bringing in things. So here we're just going to copy the fields. We can have different solutions to copy that automatically with like implementation detail. And then here we'd have tasty, okay? And then that would be better, duck, duck. And then we'd have better to be properties. Whoa. App pudding. Oh, yeah, that's not. Oh, let's make it that way here. Initialized list. Okay, so now create has, I mean, it creates our thing. And what could we reply? Like the create function has one return value. It's an error. It's great because it's simple, right? It's one thing. If you return an error there, you'll yield an internal server error, 500 error. Okay, it will be properly formatted with your error there. And depending on your configuration from your main here, for the error handling being true or false, you'll get the actual message sent to the user or not, right? More or less privacy here. And if you return nil, then it means it's all successful, but you still need to send a reply. So the context object, so if we list the definition and we run get guru here, go guru, these are the things on that context. Most of those are inherited from the requests and other things because we have embedded structs. But see this one here? It's part of our app context. It's been declared with our create pudding. See what it does? Does the job. So we generate for each response type a function we can call that will do all the serialization and such for us. So it takes out a lot of boilerplate, right, from your code. Because in the end, your code is going to look like that. Created. Boom. And that one will return, oh, sorry. Man. Because in the end, it's going to return like that. That's pretty slick, right? So what about the delete? So you know about delete, right? You know how to implement that, a deletion on a list? There's a .delete method. No, so to delete, we're going to append a store with ctxid. And then you might be wondering what the hell is ctxid +1, da-da-da. And then we'll return ctx OK, right? Which takes a list of byte, and we're going to say OK. So that deletes the context ID. What is that ID? Because in the delete pudding thing, we have a comment and an ID, right? They've been brought in. So like first class on that context. Properly typed, it's an int. Yes? You're hungry. So there's a list. There's a list of, I think GoVet or GoLint has a list of, I don't remember the name. disambiguation. There's a little thing with all the API and the SOAP, you know, all these keywords, and they'll make them uppercase. So there's a predefined list. Which is like, I'm really happy to have an ID like that because I've been annoyed with like Goify. I think it's called Goify or something. So, okay. You give it to who you want. So here we implemented delete, and now list. Now what does OK, so that's the basic thing. What does OK expect, right? It wants a pudding collection. What's a pudding collection? It's a list. So look, we're just going to return the store. That's going to be the whole thing. We return the full store. And then for the show, what if we return the index? Because in the show, we also have the ID, right? It has ID here in the pudding context. And we just return that. No issues? You think that'll compile? Yeah? Come on, come on. There's no issue there?
Well, I'm just thinking of it like having all of the delete, so it needs to be in that responsible list, but if it is kind of
So I'm not sure where you want to get with that, but I sure as hell have a bug in there. Because if we send an ID that's 999 or -2, we'll have an error, right? It's going to panic. It's going to die. Luckily, we have the recover middleware, which is not going to crash our program, but send a 500 error, okay? But we most probably want to say, if context ID is lower than length of the store, then return. And look here, we have not found. Because that happens, sorry? Greater or equal. If it's ID greater than, oh man, God, you're good. What can I give you? Okay, we're not checking the other side, but so now let's look at this. So the delete should have the same thing, right? You can't delete something that doesn't exist, and you return it not found. But see, that won't compile. If I go install that thing, undefined has no field or method not found. So that's when I realized with the guy from the other team, guy, you don't have a not found thing. How can I manage with your API? So you're going to create, modify your design, and add that. Oh, that's true. Let me add that directly to my Swagger file, to the API, right? That's how you want to do it. And then we generate the app, the Swagger file, and then we can tell our guy do whatever, right?
The pudding.go file, was that generated?
Which one?
The one you were editing.
This one here. This one was scaffolded. So that's one of the files, like the main in that directory. So look in here. We have, that is always deleted and regenerated. Client, same thing. Swagger and tools, the same thing. But these files are your implementation. So they're just scaffolded the first time, the initial time. If they're there, they're not touched. Yeah, yeah. Clear distinction. So if you add a bunch of new endpoints, like I suggest, you just rename that one, put it again, and then copy the missing bits. But if you do add a new resource, your thing will not compile anymore. It'll say, I have a missing whatever new thing, and I need it. So you'll be able to add those 3 lines, right? The stub, because it's only ever the same action name plus resource name, and the context is always probably named. So very fast, you can just drop a new you know, what I'm talking about is, like, you can just copy that line. You added another, like, it's not delete, it's blend. Well, you blend pudding's context, and you're up. Right? Okay, so now, do I have a not found? I generated things. Boom, now I have the not found properly set up to do the response. There's some response templates. So you can have also a response with a success model that will always, when up on success, like you say okay with the success, so you give it, I don't know, some details or whatnot, or the ID. So there's a lot more flexibility than what I'm showing, but still. Okay, so where are we at? So we implemented the whole thing, didn't we? We haven't tried it, right? Sorry? Yeah, I know. Okay, let me just show you how we would do it because it's interesting. I was told it was useless, but just for you. We're going to add a new resource, okay, that we would blend. And in here, we would say parent, right? And when you say parent, you're now stacking that resource on top of the, by default, show, which is get/id, on top of base path, on top of v1, right? So parent means you'll end up with, let's say, an action would blend, and then you'd have a routing post for blend with other. What? It's what? So show, yeah, you can have a function, I think canonical get thing, and you can replace it to show, but by default it's show. Yeah, so if you have a show in the parent, it'll use that to go up the ladder. So if we do that, and we have also, so we don't actually need the ID because it's inherited from the show. If we do that, and then let's say the response would be an OK, whatever, and we generate that, and let's also generate the Swagger file. And we're going to go back to the Swagger file, reload it, and then put that, replace that here. So we'll see that if we list all the operations, we'll have now this puddings. Everything is stacked on top of v1 with the ID, the blend, with other, and those are two parameters are in the path, and they're required. They're integers. You could try that operation, right, with IDs and other. Okay, so that's how you do the blending and nested paths. But you have a great flexibility to define resources, top resource, like mapping to the REST philosophy. Does that make sense? So let's try the server. I mean, we should try it, right? You think that'll install if I build that? And then I run pudding. I have the server listening on 8080, and then I can localhost 8080, right? So not found, yes, of course. Puddings. Over here, I have an empty list. I have an OK. Let me add a new one. So expose there with a, let's say, name, chocolate, pudding. So I did 201 created. Then listing the puddings again. I get the name, chocolate, Those are vendored pudding. They're a great API, right? If I say Nameo, I'll get ID, bad request, 400 matches that with the details. This is a single ID of her request, so you can easily trace in logs if someone gives you that. It's like the Cloudflare raise, right? It allow you to search your code if someone says, I got that error, where does it come from? You can trace your system with that. And it gives you attribute name of this raw is missing required, attribute name, parent raw, Cool? Is that it, man? So I mean, it runs. You can delete things. You can go through the UI. So we created from scratch the design. We built it. There's a test directory in there. It generates testing helpers. So blend, or let's look at the blend one. So blend, OK. So you pass in the little T context, and it can help you. It does a lot of the boilerplate around running your tests, right? So you would obviously test it. We're not going to do it today. But it plays with all the receives the right parameters, ID and other and whatnot, the right types. Okay, so we created the thing, we built it. Now the only thing left, I guess, would be to ship it, right? Ship it to prod. So what would be the best way to ship that to prod? Yeah, so we put that in the Docker file. So we're using Go, okay? So we're going to build a Docker file from scratch, and then we're going to add the pudding file as pudding, and then we're going to say, well, when you run that container, we run /pudding, and we're going to build it because we can do that. Cgo enabled equals 0 go build -v. So it's going to build that, put it in the directory, and I'm going to create a Docker image, all right, and ship that to prod. I don't know if we can find a way. Don't get too broad here. So. And then we want a Docker build tag, and we're going to make that a Bourget pudding 1. We're going to local directory, boom, 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 and we're going to Docker push. That will go to Docker Hub, right? Okay, so I'm shipping that 8 megabytes image. Now I need to ship that on prod somewhere. So we'll use, I don't know, maybe you know Kubernetes. So we're going to put that on Kubernetes. We could say, I have a Kubernetes cluster here, right? There's no pods running. And then we're going to run. So where's that sheet? Oh, yeah, here. So we're going to run that pudding and we're going to give it an image name, right? Pudding v1, and the port, our port is 8080. So let's run that. It's going to create a deployment and push that on a cluster, and then the pod should be running. It's running, so let's look at the logs. Okay, we got the logs. It's ready to receive traffic, but now it's living where? So I need to poke a hole to that cluster. So let's create a load balancer, right? We're going to expose that. So, and we're going to expose that little thing. It's a deployment. It's called pudding. I wanted it to receive traffic on 80, so the load balancer. That's on Amazon, by the way. So the type load balancer is going to be an ELB. And when I create that, so okay, now it's been exposed. Shoot, the thing is kind of provisioning a service. Oh, shoot, it has an external IP already. Okay, so we're almost there. I mean, how can we? Right, so if we go here and say puddings, okay, it's not there yet. So it's going to provision, but in the meantime, I can wait, and maybe I want to make some changes to the API, okay? Because I've rolled out a first version. We're going to try it right in a second. But let's go and change the implementation, because we don't want names that are all lowercase, because we hate that, right? Lowercase is so D base 3, right? So we're better than that, and we're going to uppercase all the names to upper. There's a function. Luckily, there's a function in Go that does that right away. So, and we're going to rebuild our thing. So let me try the thing. Is it ready? Who can tell me that's ready? 2. Let's try, but is that going to work? Cannot resolve yet. Shoot. Okay, it's coming through. So we have version 1 running. Let's build version 2. We're going to do the same thing. Where's that? So build, Docker build. Oh, I need to compile first. Go build. We're going to make that version 2. Does that make sense? I mean, are we following a little bit? No question right now. So build. No, sorry. It's going to be Docker build. And tag that one v2. Okay, we're not going to push it right away because we want to try the first one. Man, that's crazy. Are you reaching it? So it takes a little bit of time to provision like a humongous amount of VMs just to serve my cheap thing. Okay, should be there in a moment. Change the what? Oh, answer section. Oh, I think we have something. But if we do that, okay, cool. I don't need to do anything. That's just what you need to do. So if we want to expose and then add here, name equal chocolate, right? We got it created. Remember, that's on Amazon. And I want to list the pudding. See, I got that one, which is pretty great. But see how it added chocolate lowercase? I don't want that. I want to have an uppercase thing. So I'm going to push v2 to Docker, and I'm going to do a rolling deployment. So what Kubernetes is going to do, this is a little flashing demo, right? It's going to schedule a new pod somewhere on the cluster, and then it's going to attach to the load balancer. It's going to kill the other one, and then we'll be updated. It's going to do a rolling update like this. Pretty cool. So if you look here, getting pods, that's the number of the deployment. It's an ID there. That's the pudding thing. That's one because we asked for only one pod. We could put 70, but right now it's all in memory, so it would be bizarre. So I'm going to set the image for the deployment pudding and change the pudding pod to Bourget pudding v2 because we can do that. And if we do that, get pods, see how that was the previous deployment. This one restarted 2 seconds ago. I got a new thing here. Logs. And then, oh, shoot. Someone already sent something. So there's one guy who types very fast. Yerba buena. That would be the name, right? What happens with that? So if I query the endpoint, create a chocolate, and also list them, yeah. Gosh, so now it goes through version 2. So what did we say? We say, okay, read me. So we said at the beginning, so we're going to think of an API, revise it with you guys, implement it. We didn't test it. We shipped to prod, tweaked it, and shipped to prod again. So that's what you do with APIs, right? Yeah, that's what we like to do. So code generation is awesome because it makes, for Go at least, a single source of truth from which all the rest goes. It feels really solid to build an API that way because you know the contract with your user is going to be solid. You know all the tooling around is going to be solid, and you don't need to bother with like checking your form. You don't need to bring another form checking library that you wire in from the top to the bottom, right? It's just all there, and you don't need to touch it. Right, so, and also about the open source project, so Raphael Simon, who wrote that, as I said at the beginning, was a 5th iteration on that sort of a project. And they've been great at absorbing like contribution, managing the open source community, which is really important for me as a person. I like going with projects that have a good future. So I think Go has a good future too. And welcome your contribution, and I hope you enjoyed. 2 questions left. Yes. You didn't eat? Yeah? Yeah.
It seems great, to be honest, but I was wondering if there's a case.
Seems great, but. Okay. Sorry?
Is there a case where you would recommend it?
Well, this is for building REST APIs. Okay? Nothing prevents you from taking the mux, which is just under the service there, and attaching whatever other application you want. But like, you see, that's not for I don't know. It's for a REST API. If you're building, I don't know, streaming things on the other side, it has support for WebSocket. You can give an endpoint, which is going to be a WebSocket. Then it won't document that part. So it's really, like, if you're not building REST APIs or RPC style, that wouldn't be a fit, right? But if you're building REST API using Open API to document your things around, I mean, it's a great fit. So I'm just selling it more. But so like, for things, I don't know, I think of. Yes?
I didn't like with Golang, but
yeah.
I saw that there was a mention about like plugins for Golang so that you could generate other things.
Yeah, so there's another thing called Gorma. And Gorma, it's on the website here. That's the website. Gorma adds to that a DSL for models of databases, right? And it'll generate for you a GORM. GORM is in sort of ORM in Go. And that will generate more things. So it extended the DSL, see here, to use the Gorma DSL, and that adds models and builds from it, and whatnot. And that generates more things, like more integration. So they're extensions to the DSL, right? When we implemented the security things, well, we added to the DSL, and now it was more powerful, generated more things. And so as you've seen, maybe, in the API thing here, we can also import other packages. So kind of, say we have models in one package, we can reuse them in 2 projects because it's just importing that. The moment it's run, it's going to be added to the API, like to the slowly built API definition abstraction that runs in memory. Does that make sense?
So I think some teams do have some models with a lot of microservices. They end up with one repo with, say, all their profiles.
Right. Be possible, yeah. There's also work being done. So version 1 was released recently near GopherCon, and there's some work being done to make Goa also talk the gRPC protocol and being able to design your thing, and will generate also the gRPC stuff. Sorry? gRPC? Yeah, we're slowly adding gRPC support to Goa. Okay, so maybe net/RPC? That's not related. So gRPC is another protocol that runs on all languages. Actually, they just released version 1 very recently. They're building a massive stuff, and Google internally uses that a lot to replace their whatever skinny thing they had before for inter-process communication. And so it's a pretty solid thing. It's defined by protobufs, and then you can do bidirectional streaming. It uses HTTP2 to do bidirectional streaming, so you can do a request and you can receive many answers back. Like not just one answer, many answers. So streaming from your thing. So it's all protobuf, so it's pretty efficient on the wire. And yeah, gRPC, take a look. Does that answer the question? Any other question? Yes? Yeah, it did. I didn't use it, right? Of course. Well, actually, the way I prefer to do things, I don't know if I can show that. It's a little bit internal. But I have a file. That's one of our service metal dude, whatever. And instead of running go@gen on the command line, I prefer running it like that as code. So when I use go vendor, all the dependencies for the generation are all vendored in my repository. And from that on, like, I can give that repository to anyone. They don't need to check out anything else. Everything is in there, versioned properly for that release of Goa with all the dependencies, which is like a little tricky when you use go@gen because it's a binary, and you don't have all the source code necessarily near. Well, yeah. In that case, what I do is I put go generate to run that, right? That's my little generator. It's kind of a homemade generator, and I would put go generate. Go run genmain at the root. So go generate with but go generate can handle both. Sorry? Yes, it was. Okay, so yeah. You're talking about that here. Yeah, I replace that normally with go run genmain. That's what I do. But both will work. And for those who don't know, that little special tag here, right, that special tag, if you punch in go generate here, we'll execute that with the command.exec. So on your system, we'll execute it. And then it will, in that case, like scaffold, whatever bootstrap things. You can add many lines, sprinkle around your code. And yes, this is a built-in functionality. So it's not related to go get. Go generate will just execute what is inside the Go files. It executes that. Yeah. Right. Yes. The repository, the Git. Git, if you use Git. So what we do is we put everything in. So we generate the code, then we stick it in, and that's the sort of code we don't really read the reviews, right? We don't really review unless we're interested into what was changed. But looking at the design change is sufficient to see that it was changed. We commit them. It's not so big, right? It's not, yeah. Yes? It's a good question. Last time I had to do an upload, I think I just took the request object and dealt with it myself. Like, you have the request object. It's very, very close to, bare bones .NET HTTP2, .NET and .NET HTTP. Not sure about file uploads. Okay? Yeah?
In terms of the client,
yep.
If somebody wants to implement a client in a different
Didn't I show that? I didn't show that, right? So this here, the blend, for example. Oh, I didn't show that. Let me show you that. So the tool, and there's two things. So if you go install that, then you have a pudding CLI. Pudding CLI will have all these functions, pudding CLI, create, pudding, and whatnot, and it'll have the things, all the things with the help puddings, create puddings. See, an example automatically generated with what you can do with puddings, payload, whatnot. Okay, so that's one thing, that's a command line tool. And the other thing is the client. So that client here is generated to give you a client inside your package, and will expose, let's say, the puddings. See, we'll have structures to call your API, and to generate the path, and then to call that endpoint and manage whatever else, like, right? So it gives you a client. You can use.
Using the Swagger file, I can generate a client.
So with Swagger, you can generate some other Go client if you don't like that one, and Java. Oh, have you seen the list of tools? It's crazy. So those are open source tools. A few of them, like Node.js, will consume the Swagger file in all freaking language, and validate the Swagger, and also generate. There's a Swagger gen or something like that. Yeah, Swagger. I don't remember what. Swagger code gen generates working clients for a lot of languages. Swagger OpenAP has a great thing, great convention, I think, great achievement of humanity. Are we done? Thank you. Come back next time.